Whether you're riding a bike or teasing your wife, one thing is absolutely essential: a helmet. Have you ever picked up a motorcycle helmet and thought, how can something this light actually save a life? Yet in a crash powerful enough to crush metal, this single piece of gear stands between you and disaster. And that's because a helmet isn't just plastic and paint, it's a carefully engineered blend of science, precision, and human craftsmanship. Some premium helmets take up to 18 hours of pure hands-on work to build. No machines rushing the process. Every gram is calculated, every fiber is layered by hand, and even the final paint is applied with extreme precision. Nothing about this process is random. Today, Factory Flow is taking you inside one of the world's leading helmet manufacturers, a name trusted by professional MotoGP riders and everyday commuters alike. If you enjoy discovering how ordinary objects hide extraordinary engineering, make sure to subscribe. On this channel, we uncover factory secrets that most people never get to see. Part 1. The birth of the shell. Every motorcycle helmet begins with one mission: protecting the human brain. Unlike bones, the brain can't simply heal once it's damaged. That's why the people who build helmets don't treat this like a job. They treat it like a responsibility. Inside the factory, everything starts with fibers, not ordinary materials, but advanced superfibers that are up to 30% stronger than standard alternatives. These fibers are incredibly thin and lightweight, allowing engineers to reduce weight without sacrificing strength. The result? A helmet that feels light in your hands, but performs like armor when it matters most. These materials cost several times more to produce than standard alternatives. But when you're protecting a human head, cutting corners is never an option. In helmet manufacturing, safety always outweighs savings. Step into the molding area, and the process feels less like heavy industry and more like fine art. Every shell mold is designed in-house, and the journey begins with the first fiberglass layer. Highly trained specialists, known as shell experts, carefully hand-lay the fibers inside slowly rotating molds. Resin is applied in exact amounts, following patterns that must be perfect down to the smallest detail. Only a handful of people in the entire factory are trusted with this task. It's a skill that takes years of experience to master, because one mistake here could compromise everything. This isn't a relaxed production line, it's high-stakes, detail-obsessed craftsmanship. Each helmet shell is built from more than 20 different materials, all placed in specific positions to maximize strength. Some layers include a lightweight, net-like composite that reinforces the shell without adding unnecessary weight. Throughout the process, every shell is inspected and weighed again and again. If it's even a few grams off the target, it's immediately rejected. Before moving forward, inspectors sign their initials and log the exact weight, a personal stamp of responsibility. Once all layers are complete, the shell is sent into an oven and baked at around 100 degrees Celsius, locking everything firmly into place. The intense heat causes the resin to harden, locking the fibers together into a single, ultra-strong structure. Once the shell cools down, it's shaped not with high-pressure water jets, but with laser-level precision. In fact, this is the only robotic step in the entire factory. Water jets may seem advanced, but they can create tiny vibrations that weaken the shell at a microscopic level. Lasers, on the other hand, slice cleanly and silently without stressing the material. And despite what most people assume, this step isn't left entirely to machines. Skilled technicians closely monitor every cut to make sure nothing goes wrong. Surprising, right? After trimming, each shell is measured using micrometers capable of detecting thickness down to fractions of a millimeter. If the shell is even slightly too thin, it could flex more than designed during a crash, and that's simply unacceptable. The goal here isn't just to pass safety regulations, it's to push beyond them, using the minimum amount of resin possible to keep the helmet light without sacrificing protection. The shell may look finished, but its surface isn't perfectly smooth yet. That's why every helmet is hand-buffed using a special compound until it shines. And this step isn't just about looks, it's rooted in serious engineering. Here's the part most people don't realize: motorcycle helmets aren't designed to grip the road during a crash, they're designed to glance off it. A smooth, rounded surface allows the helmet to slide across asphalt, instead of catching on it. This reduces dangerous rotational forces, the kind that can violently twist the head and neck. In other words, the helmet acts as a controlled deflection system, not a rigid wall absorbing all the impact at once. Part 2. Painting and finishing. Now the helmet moves into what feels less like a factory and more like a high-end custom paint shop. The painting process alone involves over 10 separate steps, and nothing is rushed. It begins with a hand-applied primer coat, followed by baking and careful sanding using 3 different compounds. Then comes a second primer layer, after which the shell is wet sanded by hand once again, until only 25 grams of primer remain. The surface must be absolutely flawless before a single drop of color is applied. Each color layer takes time, 3 full days per color to be exact, and after every coat the helmet is inspected before moving forward. When it's time to apply graphics, workers hand mark each shell using precision templates to ensure perfect alignment. No guesswork, no shortcuts, just obsessive attention to detail. Here's where things get really wild. Every helmet size uses a completely different template. The same design has to be resized, repositioned, and aligned differently for each shell. That means precision isn't optional, it's everything. Quick question for you, how many people do you think in this entire factory are trusted to apply these water decals? Drop your guess in the comments. The answer might surprise you. Only a small handful of specialists are qualified for this job. Once the decals are in place, the shell is gently scuffed by hand to prepare it for the final clear coat. This protective layer is applied manually, then baked again until it hardens into a tough glass-like finish built to last. Next comes drilling, for the visor mounts, chin strap anchors, and ventilation ports. These shells are so dense and strong that drill bits wear out fast, often needing replacement after just 80 helmets. Even the rubber trim lining the helmet's edges is installed by hand, using a weather-resistant adhesive designed to stay secure through years of use, heat, and rain. Part 3. The inner structure. Now we reach what many consider the most demanding stage of all, installing the EPS liner, the foam layer responsible for absorbing impact energy. This step is so precise and unforgiving that only around 5 people in the entire factory are certified to do it. One mistake here, and the helmet never moves forward. Each EPS liner has to line up perfectly with the helmet's ventilation channels and be pressed into position without damaging either the shell or the foam. It's a precise dance between pressure and control. Too much force cracks the foam, too little, and the liner won't seat correctly. The liner itself is made from expanded polystyrene foam, commonly known as EPS, and it's often engineered with multiple density zones to protect different areas of the head. In some high-end helmets, the liner is molded as a single continuous piece with varying density throughout. This eliminates weak points that would normally exist where separate layers are glued together. And here's something many riders don't think about: helmets have an expiration date. Over time, heat, sweat, and everyday use cause the foam to harden, reducing its ability to absorb impact energy. That's why the date inside your helmet isn't for branding or style, it's a critical safety limit. Chin straps are crafted by hand and installed separately, then tested again to ensure they can withstand extreme tension. Vent scoops are bonded using high-strength adhesives that are intentionally designed to break away during a crash. This ties back to the same glancing-off philosophy. If the helmet catches on the ground, the vents detach, allowing the helmet to slide smoothly instead of gripping the surface. Everything comes back to one critical goal: reducing rotational forces. In many accidents, the twisting motion of the head can be even more dangerous than a direct impact. Next, the visor system. Interior padding and ventilation channels are installed. And none of this is random. The visor isn't just transparent plastic, it's built to release safely during a crash, helping minimize twisting forces on the neck. The inner padding is adjustable, allowing pressure to be distributed evenly across the head for both comfort and protection. Part 4. Testing and final inspection. Now comes the moment of truth. Before any helmet leaves the production line, it has to prove it can survive the unthinkable. Inside advanced testing laboratories, helmets are pushed through a brutal series of controlled experiments designed to replicate real-world crashes, only with far more precision. One of the most important is the impact attenuation test. Helmets are dropped from exact heights onto different types of anvils. A flat anvil simulates striking a road or wall. Wedge-shaped and curbstone anvils recreate sharp edges, like hitting a curb at speed. Inside each helmet, a headform fitted with sensitive accelerometers measures how much G-force passes through the shell and liner to the point where a human skull would be. If the numbers are too high, the helmet fails. No exceptions. The objective is simple, but extremely demanding: keep the force transferred to the head well below the level that could cause a concussion or serious brain injury. Next comes penetration testing, one of the harshest evaluations of a helmet's outer shell. A sharp steel striker is dropped directly onto the crown of the helmet, testing whether anything can break through to the headform inside. This simulates real-world hazards, like flying debris or sharp road edges. Only the toughest shells make it through without damage. Then there's retention system testing, which focuses on the chin strap. It might look like the simplest component, but it's the part that literally keeps the helmet on your head during a crash. The strap is locked into a test rig and subjected to intense dynamic forces, violent pulls designed to tear it apart. The buckle, stitching, and anchor points all have to withstand the load without snapping, slipping, or stretching beyond safe limits. If any part fails, the helmet is immediately rejected. No second chances. Next up are roll-off tests. A weighted pulley violently pulls the helmet backward from the front, recreating the kind of motion that could rip it off during a crash. This test proves whether the helmet's fit and retention system truly work together to keep it locked in place under extreme stress. But modern safety testing goes far beyond straight-down impacts. Many premium manufacturers, including brands like Arai and Shuai, also perform rotational acceleration tests. These simulate what happens when a rider's head strikes the pavement at an angle. Instead of a direct hit, the helmet is forced into a sudden spin to measure how effectively it reduces twisting forces, the kind that can shear brain tissue inside the skull. To combat this, advanced systems like MIPS, Multi-Directional Impact Protection System, or fluid-based slip layers are used. These allow the shell and liner to move slightly relative to each other, dissipating rotational energy before it reaches the brain. And for some laboratories, this still isn't enough. Helmets are then pushed through extreme environmental conditioning. They're frozen to 20 degrees Celsius, baked at temperatures above 50 degrees, and even soaked in water to replicate heavy rain. These tests reveal how materials behave under real stress, because a helmet that only performs well in perfect lab conditions is useless in the real world. Some models go even further, facing prolonged UV exposure and solvent resistance tests. This ensures that years of sunlight, sweat, and even fuel vapors won't break down their protective layers. Even the paint finish is tested, forced to endure stress without cracking or peeling. Every one of these tests is brutal, repetitive, and intentionally unforgiving. And passing once isn't enough. Helmets must succeed consistently across entire production batches. Manufacturers like Arai go far beyond minimum regulations, striking the shell at more points than official test standards require. They hunt for weaknesses that the rulebooks don't even mention, testing until every potential failure point is eliminated. After surviving the entire gauntlet, each helmet goes through one final human inspection. Every curve, vent, and visor mount is examined by hand. Some helmets are even signed by the craftsman who approved them, a quiet mark of accountability that says, "I personally stand behind this." From there, the helmet moves to packaging, where only 2 trusted workers are allowed to handle the final boxing. Their movements are fast, precise, and deliberate, wrapping each helmet as if sealing a promise. By the time it's ready to ship, that single helmet has passed through dozens of hands, endured hundreds of inspections, and absorbed countless hours of human focus. Every step exists for one reason, so that when a rider's world suddenly flips upside down, the helmet does exactly what it was built to do: save a life. Part 5. The human element. So the next time you put one on, remember this isn't just riding gear. It's the result of thousands of small human decisions, made with care, pressure, and responsibility, all in the name of your safety. Most people assume helmets are mass-produced by machines, but after seeing what really goes into making one, do you still believe that? Which part of the process surprised you the most? Let us know in the comments, and tell us what everyday product have you always been curious about. If we choose your idea for an upcoming video, we'll feature your name on screen. Today, Factory Flow showed you how a motorcycle helmet is made. But what about the gear that completes the ride? Should we take you inside the factories that build racing suits or riding gloves next? Cast your vote below. We're reading every single comment.